example. So let's say we have fx equal to 3x minus 9 divided by x. Okay, so first, what do? We can take out the 3. So x minus 3 over x. So how do we gonna suppose to draw the graph here? So first information that we can find, of course, we are going to find the domains. So domain, we set the denominator, we put it cannot be 0, so that's why x cannot be 0. Alright, second information, we'll go and find the x-intercept. So we set the y to 0, 3x minus 9 equal to x. So 0 times the x, so we get 0. So 0 equal to 3x minus 9. 3x equal to 9. X equal to 3. So we have the first intercept, which is 3, 0. So let's go and find the y-intercept. So y-intercept, we set the x becoming 0. Okay, be careful with this example here. Since you are dividing by 0, so your y is not equal to 0. So actually, we don't have any y-intercept, so none. Alright, so the graph. So we have a 3. So put it label. Y-intercept, we don't have. Alright. And next, we will go and find out the vertical asymptotes. Alright, vertical asymptotes is similar like how you find the domain, but this time you just set the dx denominator equal to 0, so it means x equal to 0. So plot in the graph there, x equal to 0. So it's actually on the y-axis. So this one, which is your x equal to 0. That will be your vertical asymptotes. Okay. Next, number 4, we'll go and find out whether we have a horizontal or oblique asymptote. So, and we are comparing the degree. So based on the function, the degree of the numerator is actually 1. The degree of the denominator is also 1. So whenever degree of numerator is equal to the degree of denominator, so what we will do, you just say that HA exists, OA does not exist. So the equation of the HA or horizontal asymptotes will be y equal to, you take the coefficient of the numerators and divide by the coefficient of the denominator. So it's 3 over 1 because this one is 1, this one is 3. So take 3, take 1. So means we write as y equal to 3. So we're going to plot in the graph there, y equal to 3. That will be our horizontal asymptotes, y equal to 3. Okay, so at this stage, basically we can actually complete the graph. So just one more last piece of information that you can find to guide you to finishing the graph, So they call it the interval analysis. So I just write as intervals analysis. Okay, you need to set, the function, alright, again, so is y equal to 3x minus 3 and then divide by x. So you set this one equal to 0, you set this one equal to 0. Okay, so if we set the numerator equal to 0, we get the x value will be 3, and we set the denominator equal to 0, we get the x value equal to 0. So then what you do, you need to arrange in a straight line here. So start from the small one, 0, then 3. One end negative, the other end plus infinity. So we have 3 intervals. Then what you need to do, you need to suggest a value within each intervals. So here I can pick -2, here I can pick 2, here I can pick, like, for example, 10. Okay, once you pick -2, you have to substitute. Okay, substitute this one with -2. So -2 on top, what do you get? We get the negative. -2 below, of course, we get negative below. Negative divided by negative, we get plus. Alright, second interval, which is 2. So we put on top here 2. 2 minus 3 is -1, so on top is negative. Below, we are substitute with 2, which is a positive value. So minus divided by plus, we get the negative. So the third interval, which is 10, so on top you put 10. On top will be plus. Below we put 10, of course, will be plus. So plus divided by plus, we get plus. So this one means that the graph is actually above This one, the graph is below. This one above or below where? It's actually above or below your x-axis. All right, based on this information, we have to find out the graph. So let's analyze the graph again. So from negative infinity to 0 means this whole part here. This whole part here, they say is a plus, positive. So means there will be something above the x-axis. So the one that I show in my mouse here, this part. Okay, you cannot draw anything here because if you draw anything here, there of course they will cross over here, or they will cross over the x-axis. But we found out that there's no x interval somewhere here, so the graph must be somewhere above here. Okay. Sorry, I think I moved the graph already. Yes, it should be something like this. All right. So there will be something here. So that's why you have to label the graph. Once again, I move it properly. Yes. So you should have the graph showing somewhere here. Okay. All right. Approaching the asymptotes. Once again, approaching them because you have two asymptotes here. Sorry. So they will be approaching the asymptotes, and it satisfies this information which is above the x-axis. The second interval is between 0 and 3. So basically it's referring to, we know that this one is 0. Alright, so sorry, this one will be 0 and this one will be 3. So there are something we can find out in these intervals here, 0 to 3. So it shows that it's a negative, so it's below. So it means it's something down there. And then this one is intercept. Of course, it will cross over here and come down approaching the intervals. And on the third intervals, which is this part here, so you can see it's 3 to plus infinity. So it means it's from here towards the right side, all the way here. So here it shows that it's above x-axis. So means there's something above, which is correct. So, and repeat again, don't cross over the horizontal asymptotes. So yes, so this is the graph of the rational functions.